Hey everybody, all right, pre-calculus. In this video we're going to tackle quadratic inequalities. A topic you should have definitely learned in Algebra 2, but one that a lot of kids mess up on, so let's take a look. All right, so first off, what is a quadratic inequality? A quadratic inequality is just a quadratic equation, but we are not look for specific solutions. We're looking for what values makes the quadratic equation positive, negative, or equal to 0. So again, in a traditional quadratic equation, we're looking for the 1, 2, or none, no solutions. Well, the moment we use an inequality, like a greater than sign, a less than sign, or a greater than or equal to sign, less than or equal to sign, now we're looking for what set of values produce values for that quadratic that are either greater than 0, above 0, positive, negative, same thing, right? Positive above 0, negative below 0, or necessarily equal to 0 possibly. So note that the first step is always to get a 0 on one side. So the whole point is that when we're going to tackle one of these quadratic inequalities, the first thing you need to do is get a 0 on one side of the inequality. It's the same thing with the equation, right? So that at least doesn't change. Now let's take a look at what I mean by this graphically, right? So here is a quadratic graph, and we see here are the two solutions, or the zeros. Remember, where you cross the x-axis are the solutions, the zeros, the roots, whatever you want to call them. And then you can actually see anywhere between these two values. Looks like this is -3, looks like this is +4. Anywhere between these two values, the function is negative. If you look at the graph between -3 and 4, we see negative values. So that means the interval from -3 to 4 produces negative values for this quadratic. And then any value from -infinity to -3, right? Any value over here, right, produces these positive values. Now I know it goes off the screen, but this quadratic continues all the way up. And then any value 4 or greater also produces, any value greater than 4 produces a value that is also greater than 0 or positive. So those would be any values over here. So we kind of look at these two zeros, -3 and 4, they split the graph into three parts, right? Numbers below -3, numbers between -3 and 4, numbers greater than 4. And, there's those three parts, right? You could even sometimes when I teach this, I show draw lines, right? So here is a line, it's not a very straight line. Here's another line. So there's three parts of the graph, three distinct parts of the graph. Numbers less than -3, between -3 and 4, greater than 4. And then you got to look at, what's the graph doing? What's the function doing? Here it's positive. In between, it's negative, below 0, and a greater than 4, it's back to being positive. And that's kind of what we're looking at here. So here is a quadratic, x squared minus x minus 12, greater than 0. So basically we're saying, I don't want to know what the solutions are, but you do need those, which we'll talk about in a second. But I definitely want to look at where does this equation, x squared minus x minus 12, that expression, where does that expression produce values that are positive, greater than 0? Okay, so first we need to identify the solutions. So even though we're not looking for the solutions specifically, they do help break down the graph, right? I'll go back to this graph real quick here. -3 and 4 are the solutions, but it's at those values where we either make a switch from, say, positive to negative or negative to positive. And that's what we're interested in, because when you make a switch between positive or negative, greater than 0, less than 0, those values are obviously very important to us. So the first thing you need to do is to find the solutions to the equation. Even though it's an equality, pretend for a second it's an equation and find the solutions, right? So again, do not forget, you have to always make sure that you have a 0 on one side. So like for just a hot second, I'm just going to pretend that that's an equal sign right there, and I'm going to find the solutions, which quadratics, we have three basic ways to do it. We could factor, we could complete the square, or we can... I'm drawing a blank, sorry. We can use the quadratic formula. So however you want. So this one's actually pretty easy to factor. So I have x and x. That's how I'm going to get an x squared. 12, first thing that comes to my mind is 4 and 3. And if I make it a -4 and a +3, that's going to generate that -1 in the middle. So just to double check that, x times x is the x squared. -4 times 3 is then -12. And then the outside 3x, the inside -4x makes that -x on the inside. So that means x equals 4 or x equals -3. So those are my solutions, right? But again, this is not an equation, this is an inequality. But the solutions are where we make a switch from being positive or being negative, right? So the next thing we need to do is we find the values for x that allow the expression to be positive, greater than 0. Because that's what we're looking for, right? I mean, that's what the question says. We're saying, hey, where does x squared minus x minus 12, where is it greater than 0? That's a greater than sign right there that I'm boxing up. So we want to find positive. Greater than 0 means positive. Where are we positive, okay? So here is how we do that. It's actually really, really simple. We make a number line, and we put the two solutions on that number line in order, so make sure the -3 goes first and the 4. It's got to be, this is a number line, right? You got to go in order, left to right. And then the first thing I understand is this. I'm not allowed to equal 0. So I'm going to put open circles at -3 and 4 because -3 turns this into 0. If I plug -3 in for x, I'm going to get a 0. If I plug in 4 for x, I'm going to get a 0. I don't want to equal 0. It doesn't say or equal to, so I'm going to use open circles there. Then I'm just going to test. I call just test values, right? Test, pick any number you want that is below -3, like -200, honestly, pick -200, doesn't matter. Plug it in and see what happens. You could plug it into the original quadratic in this form, or you could even plug it into the factored form, doesn't matter. Sometimes the factored form is a little bit easier, it's up to you. Feel free to use the calculator as well, I don't care. -200 minus 4 is -204. The only thing I really care about is negative. Right? Because remember, all I care about is that I want to be greater than 0. I don't necessarily care what the number is. I don't care if it's 20, 30, or 40. Just care that it's greater than 0. So if I plug -200 in, I get -200 minus 4, which is a negative number, obviously -204. And then I do -200 plus 3, that's going to be -197. Regardless, again, it's still negative. But then you got to multiply them, right? And what happens when you multiply two negatives? You get a positive. So that confirms that any number below -3 does produce a positive. Now, we see that in the graph, right? The graph shows that. I'm going to erase all this because I've gotten so much stuff in this graph. But we see that here's -3 right here, and we see that any value below -3 produces a positive number. And this keeps going and going and going and going. So -200, which is way down here somewhere, eventually will produce a positive number. All right, then we have to check numbers in between -3 and 4. Zero's a really easy one. You can pick any one you want. I'm going to pick 1. So if I pick a number 1, plug it in. 1 minus 4 is -3. It's negative, right? It's negative. Excuse me. I picked 1. 1 minus 4 is -3. It's a negative. 1 plus 3 is positive 4. That's a positive. And what happens when you multiply negative times a positive? You get a negative. So that confirms that any number in between -3 and 4 produces a negative number. Once again, check that out. I see that in the graph. Any number between -3 and 4 is a negative value. Okay, I checked 1, and it does. It is a negative number. But you only have to check one number, right? It's a nice thing about it. And then the other thing I'm going to do is I'm going to check numbers greater than 4, so pick any number above 4. Heck, you could pick 1,000,000, honestly. 1,000,000 minus 4, I don't really care what number it is, it's positive. 1,000,000 plus 3, it's positive. A positive times a positive makes an overall positive. So that means any number greater than 4 also produces a positive. So these numbers, and again, I want to make sure I say this. I knew all this ahead of time because I had a graph. I probably should have led with this, is we want to be able to do this without a graph, without looking at the graph. We want to be able to know where's the graph positive, where's the graph negative, where's the graph positive, wherever, without a graph. So the graph we had first that we were able to see this, but now we could do this without a graph. Okay, so now I know the two answers because I want to be greater than 0. This expression is greater than 0 from -infinity to 3, interval notation, I love that. No bracket because at -3, I'm equal to 0. I don't want to be equal to 0. And then the other half of the answer is any number starting at 4 going towards infinity. And usually when there's two answers like this, we put a little U in between them, that unions that just brings them together. It's saying this and this. Okay. So -infinity to -3 or 4 towards infinity. Those are our two solution sets. The only numbers that do not work are between -3 and 4, and also -3 and 4 themselves do not work because they make 0. All right, so let's run through the steps here real quick, because I know I went through a really easy problem in 10 minutes. But step 1, get a 0 on one side. Step 2, find the solutions if it was an equation. Step 3, make a number line with those solutions on it. Step 4, start testing out each portion of that number line to decide, are those values positive or are those values negative? Then you got to look at the inequality and decide what you want. All right, let's jump and do another example here. All right, so brand new example. How do we tackle it? Step 1, I need a 0 on one side. So 2x squared plus 3x minus 20 less than or equal to 0. Step 2, got to find the solutions if this was an equation. I'm going to attempt to factor this, but again, it might be a little bit of trial and error. Let's find out. So 2x times x is the only way to split apart at 2x squared. Now I'm going to do a little bit of trial and error with this 20. So let's see. The first thing that pops in my mind is 5 and 4. So I got a 5 and I got a 4 here. Let's see. On the outside, that's an 8x, 2x times 4. On the inside's a 5x. And I'm thinking, ooh, I like this because an 8x and a 5x could make a 3 if the 8 is positive and the 5 is negative. So I literally didn't mean for that to happen. I got it on the first try. So that's the luck of it, right? Sometimes, if you get on the first try, other times it takes a little bit of time. But here we go. 2x times x is the 2x squared. Outside is -5 times 4. That makes the -20, or excuse me, that was the last. And then outside's an 8x. Inside's a -5x, that generates the -3x, positive 3x in the middle. All right, so that means my two solutions are, and again, if you need to do a little bit, I call it dirty work, right? Anytime you got to do some work on the side, dirty work. Add the 5, divide by 2 is going to be 5/2. And then obviously the other ones you could probably do in your head. Subtract the 4, you're going to get -4. All right, so if I make my number line now, I'm going to put -4 first because it's on the left side, and then 5/2. If you don't know it, 5/2 is 2.5. Okay. So first thing is I'm allowed to equal 0. It says or equal to 0. So that means I want filled in dots. That means these are going to be brackets because I'm allowed to be those numbers. -4, if I plug -4 in for x, it's going to make me 0, and that's going to result in a solution. If I plug in 5/2 right here, 2 times 5/2 is 5. 5 minus 5 is 0. That's going to produce a solution that works because of the or equal to. All right, now I just got to test my numbers. I'm looking for negatives. I'm looking to be less than 0. So now I just got to do some test numbers. So again, be dramatic. It doesn't matter. Like -200. 2 times -200 is -400. -400 minus 5, negative. And some people get to figure that out pretty quickly on their own. -200 plus 4, going to still be negative. But 2 negatives make a positive. Yay. All right. So those numbers are positive. Oh, but I don't want positives. I'm looking for negatives. Okay. Well, let's move on. Try a number between -4 and 5/2. Let's try 0. If I plug in 0, I'm going to get 2 times 0 minus 5, which is -5. 0 plus 4 is +4. That's a positive. A negative times a positive is a negative. So those numbers are going to be negative. I like negatives, right? I want to be less than 0. And then find on the far right, a million. 2 times a million minus 5, positive. Million plus 4, positive. 2 positives make a positive. So the region that contains the answers I'm looking for is in between -4 and 5/2. So my answer is bracket -4 to 5/2 with the bracket. Why brackets? Because I'm allowed to equal 0, which is what happens at -4 and 5/2. If I were to make a graph of this, here's -4, here's 5/2. The graph is going to do something like this, where in between here and here, I am below the x-axis, hence negative. Easy, right? So simple. All right, here's another one. Let's just try this one out. All right, got to get a 0 on one side. So I have 6x squared. Subtract the 4x over. That's going to be -5x. Add the 2. That's going to be -4, less than or equal to 0. So that means I'm allowed to equal 0, and I'm looking for negative numbers. Let's go ahead and factor this. We're going to try to factor. We'll see. All right, first thing that pops in my mind for 6x squared is 3x and 2x. That's going to make a 6x squared. And again, trial and error at this point. Let's just try a 2 and a 2 for 4. Outside 6x, inside's 4x. A 6x and a 4x is never going to get you a 5. So we got to try something else. The only other way to get 4 is 4 and 1, right? So let's try 4 and 1. So outside's 3x, inside's 8x. Ooh, a 3x and an 8x could get a negative 5. I just want the 8 to be negative and the 3 to be positive. So let's just double check this. There's my 3x squared. There's my negative 4 in the back. And then a 3x on the outside, a negative 8x on the inside makes the negative 5x right here that I love. So I'm good to go. Awesome. All right. So this means that x equals, add the 4, divide by 3. So that's 4/3. Subtract the 1, divide by 2, that's negative 1/2, okay? I hope you guys could do that without showing work. If you need to show the work, go ahead, but I assume you could do it on your own. All right, so now I'm gonna make my number line, and I'm gonna put them in order. Negative 1/2, 4/3. I am going to fill in dots because I'm allowed to equal 0. I'm allowed to equal 0 right here, so those numbers are gonna need brackets. All right, then you just gotta do your test points, right? So let's pick, again, negative 300. 3 times negative 300 is negative. 900 minus 4 is going to be a negative. Negative 300 times 2 is negative 600 plus 1, going to be a negative. 2 negatives make a positive when you multiply them. And if you don't like plugging that test number into the factored form, you could plug that test number into the quadratic form as well. It works a little bit trickier, but listen, you still have to figure out if you're going to get a positive or negative is all that matters. All right, pick a number in between. The easy one is 0. 3 times 0 minus 4 is negative 4. 2 times 0 plus 1 is positive 1. A negative and a positive makes a negative. And then pick a number greater than 4/3. 5. 3 times 5 is 15. 15 minus 4 is positive 11. 2 times 5 is 10. Plus 1 is positive 11. You're going to get a positive number on that side. So again, remember, what's the equation want? The equation wants me to be less than 0 or equal to. So that means I'm looking to be negative. So my answer is bracket negative 1/2, comma 4/3. Any number in that interval is going to make me happy. All right. Now, what I just went through is how to do all of this without a graph. Listen, I want you to understand that you can make, with a graph, it's actually a lot easier, way easier to figure this all out, right? So if you can graph the function and find the solutions or zeros, it will become very simple to give your answers. All you got to do is look at the graph and say, ooh, there it's underneath the x-axis, negative. Oh, over there it's above the x-axis, positive. So here is a problem that we're going to do with a calculator to show you how to do the graphing. All right, so step 1 is obviously still to get 0 on one side, but now I'm just going to jump to my calculator here. Hit y equals, go ahead and type in the x squared minus 4x plus 1, and then I'm going to do a zoom 6. Zoom 6 is your standard zoom, 10 up, 10 down, 10 left, 10 right. And here it comes. All right, so now I clearly see that there are 2 zeros. Can't really see exactly what they are. It's a little bit of an estimating game. It looks to be somewhere between 0 and it's kind of tricky, right? So don't just estimate, too quickly, but you see the point, right? So I definitely see that between those 2 zeros, I'm negative. Outside of them, to the left and to the right, I'm positive. So how do you find zeros on your calculator to get those? Well, assuming somebody's touched this at some point, but let's go over it real quick. So if you hit second trace, so second, then the trace button, this is where you could calculate values with a graph. So I'm going to click, number 2 is to find the zeros. Now it says left bound, so that means it wants me to click my mouse or pointer, whatever, move it with the arrows anywhere to the left. So I'm going to try to find this first 0 right here. So I'm going to move my cursor anywhere to the left. Now it wants me to move it anywhere to the right of the 0. And then it wants me to guess, so just put your cursor as close as you can to the 0. And there it is, 0.2679, but that's an approximate answer. I don't really like that, but okay, I could write that down, 0.2679, okay. Let me find the other one real quick. So second trace again, go down to 0, and then again, click anywhere to the left this time. Left would be to the left of the second 0 I'm looking for. Anywhere to the right, and then guess somewhere at that middle point. Okay, so 3.732 0.21 if I round that correctly. Okay, but those are approximate answers. So, I mean, if the directions say to give decimals, well, then I guess you're okay with those answers. So the answers would be, I want to be greater than 0, right? It says greater than or equal to 0. So that would mean any value left of the 0.2679 and any value to the right of 3.7321. So if I was looking for an answer with approximations, the answer would be negative infinity to 0.2679. Bracket, sorry. Oh my gosh, bracket, because it says I'm allowed to equal to. So that means the zeros are solutions. And then another answer would be a bracket 3.7321 towards infinity. So anywhere on the outsides of those two zeros, and I'll show the graph one more time, anywhere to the outside of those two zeros are going to be my solution sets that produce numbers that are greater than 0. All right, but what if I say, hey, I want the exact answers. I want the exact answers. That means that we need to find a way to get these values exactly, not these ugly, crappy decimals. So how am I going to do that? Well, let's just talk a little bit about here. The fact that I'm not getting nice, simple values, whether that be whole numbers or terminating decimals like 3.25, that tells me right away that these are irrational, which means factoring is not going to work. You could try to factor it, but I'm going to tell you right now, impossible. So the next thing you could do is the quadratic formula, or you can complete the square. I'm going to go ahead and use the quadratic formula because the quadratic formula always works without any hassle. So the opposite of b is positive 4 plus or minus the square root of b squared is 16. Guys, please know that anytime you square a number, you always get a positive. It should never be a negative number for b squared. Minus 4 times a is 1 times c is 1, all divided by twice a. 2 times 1 is 2. So let me kind of clean this up a little bit here. So I get 4 plus or minus the square root of, let's see, let me try to do this in my head. 4 times 1 is 4. 16 minus 4 is 12, all divided by 2. I could clean this up because please, oh my gosh, you got to make sure that you reduce square roots. Oh, I'm going to take points off. You better believe it. So 12 is 4 times 3. So the 4 can come out as a 2 because it's a perfect number, but the 3 stuck in there. All divided by 2. I'm actually totally okay with that answer, but you could even further reduce it by dividing everything by 2, since it says divide everything by 2. So 4 divided by 2 is 2. 2 radical 3 divided by 2 is radical 3. So there's my two answers, 2 plus or minus radical 3. I mean, look at that, 2 plus or minus radical 3. Hope everybody understands that. So 4 divided by 2 is the 2. 2 radical 3 divided by the 2 is just radical 3. So those are these numbers right here. Those are these numbers right there, but just exact. Let me prove that to you. If you don't believe me, let's just prove it, right? 2 minus the square root of 3. Boom, there's the 0.2679, but now it's not approximate, it's exact. 2 plus the square root of 3. Boom, there's the exact 3.7321. So now a much better answer would be negative infinity to 2 minus the square root of 3, bracket, and then union, which means continue over to the other interval of 2 plus radical 3 towards infinity. So those are the two spots on the graph where I am greater than 0 or equal to 0. That's on the outsides. So cool problem, definitely a trickier one because it has these non-factoring, so you got to do a little bit more work. But I also want you to understand that you could use a calculator to understand where am I above 0, where am I below 0, instead of doing the test point. So if you do have a calculator and you want a graph, you could do that to figure out where you're at instead of testing values like what we were doing earlier. So at the end of the day, make sure that you understand that there could also be other possibilities here, right? Imagine that every example we've looked at so far had a range of values that were the solutions. There could be no solutions. Imagine a graph that was like this, right? There are quadratics that could look like that. It's a problem, right? It's entirely above the x-axis. So the entire solutions, every single value is greater than 0. So if I ask, where is this quadratic less than 0? You would say no solution. Because this quadratic has no zeros, so it never dips below 0. Never. Let me clarify that. It never dips below 0, so there are no negative answers ever. So if I ask you, hey, where is this quadratic less than 0, you would say never, no solutions. Or, right, what if I said, where is this quadratic greater than 0? Well, you would say all numbers. Every single value would produce a number greater than 0 because the entire parabola is above 0. So, you know, you think about it, when a parabola does this, you have a possible range of answers, right? Between your less than 0, outside your greater than 0. But when your parabola is entirely above or maybe even entirely below, then you either have no solutions if you can't be positive or can't be negative, or you have all solutions if you're entirely negative or entirely positive. All right, a little bit longer video, sorry, but hopefully that all makes sense in terms of how to solve a quadratic inequality. Time to practice.